Good morning. I am Bharath O. I am from ECE department final year. I am from Welding High-Tech Dr. Rangarajan, Dr. Satyamurthy Engineering College. My teammates are Manoj K.
Good morning.
And Mohamed Fayaz.
Good morning.
And our project title is Deep Learning Based Classification of Biodegradable and Non-Biodegradable Material using CNN. And our project guide is Ms. Divya, Assistant Professor, ECE department. And moving on to our project explanation. As our project title is Deep Learning Based Classification of Biodegradable and Non-Biodegradable Material using CNN. The objective of the provided abstract is to highlight the challenges posed by carbon emission and the persistence of plastics in ecosystem, and to process the use of biodegradable plastic as an potential solution. The abstract aims to empathize the need for research, and it discusses various aspects related to plastic waste management and environment and socio-economic impact. The abstract also introduces an innovative approach utilizing deep learning techniques and especially convolutional neural network for the classification of biodegradable and non-biodegradable waste. The implementation of this project model using the Django web framework is also mentioned. Moving on to the objective briefly, the effectiveness of deep learning techniques in waste management by leveraging CNN abilities to capture colors and textures for waste classification. We are going to train a CNN model using an image dataset containing samples of both biodegradable and non-biodegradable waste materials, and we are going to evaluate the performance of the CNN model in accurately classifying waste materials and applying neuron-wise or the layer-wise visualization method to understand how the CNN model identifies and distinguishes waste based on visual features. And at last, for the output, we are going to utilize the Django web framework to deploy the trained CNN model as an solution. Moving on to introduction, as biodegradable substances are naturally degradable, such as bacteria, fungi, water, oxygen, etc. Decomposition is the breaking down of complex organic material into simple units. So, however, adapting the biodegradable plastic in the global market remains limited and requires further research and efforts. So, moving on to our literature survey based paper 1. The title is the analysis of the biodegradable non-biodegradable material using selected deep learning algorithms. This paper was published in the year 2021, and the idea of the paper is the CNN models, the neural network technique, performs steps such as pre-processing and feature extraction. And in this paper, they have used the image dataset with 5430 images, whereas 70% of this dataset was used as training data, and 15% as validation data, and 15 more as test data. So one of the deep learning methods the pre-trained neural network uses here in this paper is AlexNet. And moving on to the next paper, the methodology is to assess the biodegradability of the bio-based polymer, current knowledge and existing gaps. This paper was published in 2022. This review aims to point out a current standard that can serve as a basic for the categorization of biodegradation profile in different environments. And next, the influence of non-biodegradable waste on mechanical property of concrete, a neural network approach. And the stage of image processing to achieve more quality and accuracy in detecting classified images. Approaching the conventional segmentation and counting of cells is considered as an essential step that helps to extract features, and the image analysis will also perform faster and more accurately. and predicting biodegradability using thermodynamic descriptions. And this paper carries on with the ability to predict the biodegradability of a given compound uh, is crucial in understanding the fate of the compound in the environment. Here, this paper presents a novel prediction method utilizing neural network and other physical or chemical data set besides structures. The next paper's title: Prediction of Biodegradability from Structures. So, this paper, the aim of this project is to assemble sets of structural rules governing the potential microbial degradation of chemicals. These rules will provide tools to take into account the biodegradability aspects of the product and all precursors in the production process early in the product development. So, the paper described above all is as used as in reference paper, and moving on to the existing system, which is the classification of biodegradable non-biodegradable material, was done using deep learning methods, and CNN performs steps such as pre-processing and feature extraction in classification. As the existing method from base paper 1 as used, the model accuracy which I have used in the which we got from the AlexNet, a CNN model architecture, which based on single architecture, the AlexNet has accuracy of 96.3%. So, in our proposed system, we have compared the performance of VGG and LeanNet architecture in terms of classification accuracy and computational efficiency. We evaluate their effectiveness in distinguish between biodegradable and non-biodegradable waste using a dataset consist of diverse waste material. We are including a dataset which has both biodegradable and non-biodegradable waste as to train with CNN model of VGG and LeanNet architecture. So, by comparing the two architectures, we aim to identify the most suitable CNN model for waste classification, considering factors such as accuracy, efficiency, and ease of implementation. So, in this project, we are going to train a CNN model using an image dataset consisting of samples of both waste materials. So, in this, we have evaluated the performance of the trained CNN model in terms of accuracy, precision, and F1 scores. So, the proposed system block diagram for this model, CNN model, we have the raw images, that is the dataset we are going to use, and we build the sequential module which we are going to train in a CNN train, and CNN weights is the included factor which produce the output and which has classified the images based on the training set, and it will classify the biodegradable and non-biodegradable materials separately. So, system integration, the hardware requirement is a laptop, Windows and i3 processor, RAM with higher than 4 GB RAM, and with ROM of 100 GB, and software requirement is VS Code and Anaconda Navigator and Jupyter Notebook. The advantages of this project is improved accuracy. The main factor we include here is we have increased the accuracy based on two architecture, and the use of deep learning algorithms enables the system to learn and improve its accuracy over time, leading to be more effective circuit solutions. Dependence on data quality. The accuracy of system depends heavily on the quality of the data it is trained on. If the data is not of high quality, the system performance may be compromised. So, these are the advantages of this project. Moving on to the result, and the result, we have deployed the model into the Django framework and predicted the output. As the image you can clearly see, we have to choose an image of any category which classifies the image as is biodegradable or non-biodegradable. So, here you can see an image of mouse uploaded with this that is made up of plastic. So this is a non-biodegradable image, and the result obtained were architecture with a high accuracy rate. Image classification could be achieved by means of deep learning techniques. The benefit of using CNN for waste management include improved accuracy sorting accuracy and environmental sustainability. And the reference paper. Thank you.
Thank you for giving the opportunity to gain knowledge and experience from this project.
Thank you to our guide, mentor, and project coordinators and management to guide us. And thank you.
Thank you.